Welcome to the deep dive. We take complex topics and really try to boil them down into something genuinely fascinating. Today we're doing a deep dive into something pretty remarkable, actually. It's about how these cutting edge fields, STEM, robotics, AI, machine learning, computer vision, how they're being introduced to kids, like right now. It's really transforming how they see the world. So our mission today, using sources like the STEM, robotics, AML, computer vision learning for kids, PDF, is to pull out the key insights. We want to explore not just what these fields are, but really why they matter so much for the next generation, make it understandable, exciting, show you their incredible importance. So let's unpack this. Starting with STEM, what does that acronym truly mean when we're talking about young learners beyond just the letters?
Yeah, it's a great question because STEM, it really goes way beyond just teaching science, tech, engineering, and math as like separate classes. It's much more of an interdisciplinary approach. It shows kids how these fields connect, how they work together to solve actual real world problems. Think of it as a more holistic way to look at challenges.
I like that. Holistic. So it's less about memorizing formulas and more about like a way of thinking, a mindset.
Exactly. A
Because
mindset.
because if you integrate them, you're not just teaching physics, you're building their problem-solving muscle, right? Helping them spot challenges, figure out creative, logical solutions. That's critical thinking right there.
Precisely. And that hands on integrated way of doing things, it naturally sparks innovation. When kids get projects where they have to think across these different areas, it inspires curiosity. It makes them want to explore. They're not just learning facts, they're experimenting, discovering. And that really prepares them to be innovators later on, especially in this tech driven world.
Yeah. Okay, so problem-solving innovation. Yeah. Why is it so important to start this early with kids? What's the big benefit?
Well, introducing these concepts through stuff they already enjoy, like playing with building blocks or simple coding games, it helps build this lifelong love for learning because it's fun. It doesn't feel like homework. It feels like play.
Right.
And doing it early builds these crucial foundational skills like programming a really simple game teaches computational thinking, breaking big problems down, and spatial awareness too, which is huge for engineering. Plus, making it accessible and engaging early on opens doors for kids from all sorts of backgrounds. They might not otherwise see themselves doing this kind of stuff. It broadens the talent pool.
And looking further out, how does this early STEM exposure really connect to future jobs? What's the long game?
Oh, the long game is huge. There's this massive and still growing demand in STEM fields, robotics, AI, biotech, you name it.
Yeah.
So by getting involved early, kids are building what we call future readiness.
Future readiness. Okay.
Yeah, and it's not just about specific jobs today. It's about developing adaptable skills, critical thinking, creativity, digital literacy, skills they'll need for jobs that honestly might not even exist yet, especially with, automation changing things so quickly.
Right.
And beyond just getting a job, STEM skills foster entrepreneurial thinking too, teaching kids to spot needs and build solutions, maybe an app, maybe a physical product. It's empowering.
Okay, so from the broad world of STEM, let's zoom in on something really tangible, really exciting.
Yeah.
Robots. When we talk about robots, what are we actually talking about? In simple terms.
Yeah, robots. So at its core, a robot is basically a machine that's programmed to do specific tasks. And robotics, that's the whole field of tech focused on designing them, building them, using them. They can be incredibly complex or surprisingly simple things we use every day.
And we really do see them everywhere, don't we? Like, you think factory floors, but it's also those robotic arms building cars. Or, wow, surgical bots in hospitals. Even like my robot vacuum cleaner bumping around the living room. That's a robot.
Exactly. Perfect examples. And for kids, learning robotics early is so valuable because it's not just about the building part. It's super hands-on. It develops problem solving, logical thinking when they code it, and those basic engineering ideas. Skills that honestly help everywhere, not just in robotics.
You said they perform specific tasks. How do they actually do that? Like, what are the main parts inside? What makes a robot tick?
Good question. So a robot usually has a few key parts working together. First, you've got sensors.
Sensors, okay.
Yeah, these are like the robot's eyes and ears.
Yeah.
They help it sense its environment, detecting light, sound, distance, maybe even touch, kind of like our senses.
Right.
Then there's a control system. That's the brain, usually a processor or a microcontroller. It takes all the info from the sensors and makes decisions. Tells the robot what to do.
The brain. Got it.
Next up are the actuators. These are the parts that actually move. Motors, joints, grippers. They let the robot walk or pick things up or interact.
Okay, so sensors, brain, movers.
Exactly. And finally, you need a power source. Batteries usually, or sometimes plugged in. And understanding how to manage that power actually teaches kids about energy efficiency too.
That's a great breakdown.
Yeah.
So, if a kid wants to actually try building something,
Mhm.
what are some fun, practical projects they could start with?
Oh, there are some really fun beginner projects that teach these ideas playfully. Kids could make a light chasing robot. It uses light sensors, photodetectors, and some simple code to move towards a light.
Yeah.
Teaches sensors and basic algorithms.
Cool.
Or a line following robot. That's a classic. Build a bot that uses sensors underneath to follow a black line on white paper. Great for learning about sensor calibration.
Yeah, I've seen those.
Then maybe an obstacle avoiding robot. You program it to use distance sensors like ultrasonic sensors to detect things in its path and, well, navigate around them.
Okay.
And even simpler mechanically is building a robotic hand out of cardboard, straws, and string. It's a great way to learn about basic mechanics, levers, tendons, controlled movement. Super hands on.
That sounds really engaging. Okay, shifting from the physical robot to uh, the intelligence behind it. Let's talk AI, artificial intelligence. How do we explain AI simply? It sounds so big.
Yeah, AI can sound big, but the basic idea is creating systems, computer systems, that can do tasks that normally need human intelligence. Think of it like intelligence mimicry, getting machines to learn or solve problems or understand language or make decisions. It's not about being human, but doing some of the thinking tasks humans do.
Intelligence mimicry. Okay, so where are we actually seeing this AI every day? Sometimes maybe without even realizing it.
Oh, it's woven into so much now. Think about virtual assistants like Alexa or Siri or the Google Assistant. That's AI understanding your voice, figuring out what you mean, and responding.
Right, use mine all the time.
The personalized recommendations you get, Netflix suggesting shows, Spotify suggesting music, Amazon suggesting products. That's AI learning your tastes.
Mm-hmm.
Many smart devices in your home thermostats that learn your schedule, security cameras that tell a person from a squirrel they use AI to adapt, and even chatbots online. When you ask a question on a website, often it's an AI handling the basic questions first.
That makes sense. Okay, now AI and machine learning, ML.
Mm-hmm.
People use those terms like interchangeably sometimes. What's the actual difference?
That's a really common point of confusion, yeah. So think of artificial intelligence, AI, as the big, broad umbrella. It's the overall goal, creating machines that act intelligently. Machine learning, or ML, is a specific way to achieve AI. It's a subset.
Oh, okay, a subset.
Exactly. ML is about giving systems the ability to learn and improve from data without being explicitly programmed for every single scenario. So, AI is the goal smarter systems. ML is a powerful tool, maybe the main tool right now, that lets machines learn from patterns and data to get smarter. Like an AI assistant uses ML to understand your voice better over time.
Okay, let's unpack the learning part. How does a machine actually learn from data? It sounds kind of magical.
It does sound magical, but it's actually pretty logical. The simplest way is learning from examples. Imagine showing a kid tons of pictures cat, dog, cat, not a cat until they get it. Machines do something similar, but with way more data.
Okay, like flashcards for computers?
Kind of, yeah. Often it's supervised learning. Humans provide labeled data. This picture is a cat, this one is a dog. The machine studies these labeled examples and figures out the patterns, shapes, colors, textures that define a cat versus a dog. The labels supervise the learning.
So humans are the teacher providing the answers first.
In supervised learning, yes. The machine then finds the underlying patterns in that data to make its own decisions about new unlabeled pictures later on. There are other types too, like unsupervised learning, where it finds patterns on its own in unlabeled data, and reinforcement learning, where it learns by trial and error, getting rewards.
So if it learns from examples and patterns, how does it get to the point where it can actually predict things, like new things it hasn't seen before?
Right, that's the goal. It happens through the training process. The computer uses all that data it was shown to build a model, like studying really hard for a test. It identifies relationships, trends in the data.
Okay.
Think about weather forecasting. They predict tomorrow's weather based on patterns from decades of past weather data, right? Or how you might guess if fruit is ripe by its color and feel you've learned those patterns. And really importantly, there's usually a feedback loop. The machine makes a prediction, gets told if it was right or wrong, and adjusts its model. It learns from its mistakes, gets better over time.
Constantly refining.
Mhm.
Okay, now let's move to how machines see. Computer vision, CV. What's that all about?
Computer vision, yeah, it's another fascinating field within AI. It's basically about enabling computers to, well, interpret and understand visual information from the world around them, like mimicking human sight.
Giving computers eyes.
Kinda. Key ideas are things like image recognition, knowing what's in a picture, object detection, finding specific objects in an image or video, pattern analysis. It uses techniques like deep learning, neural networks to make sense of all the pixels. For kids, understanding CV helps them grasp how machines can process images, which is, everywhere now.
Uh-huh.
Fosters that curiosity about tech and the visual world.
It really is everywhere.
Yeah.
So where are some surprising or, really impactful places we see computer vision being used?
Oh, the applications are incredibly diverse now. Autonomous systems, self-driving cars are a huge one. CV lets them see the road, read signs, detect pedestrians, other cars. Absolutely critical.
Right. Can't drive without seeing.
In healthcare, it's making big strides, analyzing medical images, x-rays, MRIs to help doctors diagnose diseases, maybe spotting tumors or other anomalies earlier.
Wow.
For wildlife monitoring, conservationists use CV with camera traps to automatically identify animal species, track populations without disturbing them as much. And even in entertainment, those fun filters on social media that put masks on your face, augmented reality apps on your phone, that's often computer vision tracking your face and overlaying graphics.
Ah, okay. So that's how those work. Those are some serious applications and some fun ones too.
Yeah.
Are there ways for kids to actually experiment with CV themselves, like hands-on?
Absolutely. There are some great tools now for fun CV experiments. Kids can play with online platforms for object classification, upload a photo, see how the machine labels things, and it helps them understand how it works.
Like, is this a cat or a dog? But with a computer.
Exactly. They could also do simple projects with a webcam, and basic coding for color tracking makes something follow a red ball in the video feed, for example, or introduce them to handwriting recognition.
Mm-hmm.
There are simple tools where they can write letters and see the computer try to convert it to digital text.
Mm.
And using platforms like Scratch or beginner-friendly libraries, they can definitely explore face detection, make a little program that draws boxes around faces and pictures. Shows the core idea really clearly.
This is all amazing stuff. But wow, it sounds like a lot. If a parent or a kid wants to just get started, where's the best entry point? How do they get hands-on?
Yeah, it can seem like a lot, but there are fantastic websites and tools designed just for kids. Super approachable. For general interactive STEM, platforms like Tinkercad are great for online 3D design and even simulating electronic circuits. Really hands-on.
Tinkercad, okay.
Science Buddies has just a massive library of project ideas, searchable by topic and age. For more gamified learning, Brain PLP and Mystery Science use cool animations and activities.
Right.
And for coding basics, you can't beat Scratch. That visual drag and drop interface is perfect for making games and stories. Code.org also has excellent structured courses for all ages.
What about the physical building side? For robotics, kids who like getting their hands dirty?
Oh yeah, for robotics kits, Lego Mindstorms and VX, robotics are kind of the gold standards. They're modular, you build robots, program them. Great for problem solving.
Lego is always a hit.
Definitely. For maybe slightly younger kids or simpler entry points, Sphero, those little programmable balls, and Ozobot, which follows lines you draw, are super intuitive.
Right.
And for kids ready to go a bit deeper, Arduino microcontrollers and Raspberry Pi single board computers open up a huge world of possibilities. There are massive online communities with tutorials for almost anything you can imagine.
So lots of options for robotics. What about specific tools for AI and ML exploration that are fun?
Yeah, there are some cool ones there too. Teachable Machine, it's by Google, is awesome. Lets kids train simple AI models using their webcam, like teach it to recognize different hand gestures or objects. No coding needed. Very visual.
That sounds fun.
Cogniments is another platform built on Scratch that lets kids create games and projects incorporating AI training. And Scratch itself now has ML extensions, so kids can add machine learning blocks right into their existing coding projects.
Integrating it right in.
Okay.
And beyond specific tools, what about general creative challenges or activities that really boost this kind of learning?
Absolutely. Those hands-on challenges are key. Things like a bridge building challenge using just straws and tape, or spaghetti and marshmallows. That really gets them thinking critically about structure and design.
Yeah, classic.
Or team projects like designing a simple pulley system to lift a small weight. Teaches collaboration and basic physics principles.
Mm-hmm.
Even making a soda bottle rocket. It's fun, a bit messy maybe, but it powerfully demonstrates things like force, pressure, gravity in a way they won't forget. Practical application.
Going back to the robots for a sec, what specific skills click into place when kids are actually building and coding them? What do they really gain there?
Well, it's a fantastic combination. Assembling the robot kits teaches core engineering skills, how gears work, how sensors connect, motor functions. It makes abstract ideas tangible.
Right. You see how it fits together.
Exactly.
Mhm.
And then using block based coding, or maybe simple text coding, teaches programming logic sequences, loops, conditions, debugging.
Mm.
It's intuitive. And importantly, they can customize their robots. Change the design, change the code, make it do something unique. That really fosters creativity and problem solving. It's their own creation. And finally, related to AI and ML, there are even games designed for kids, like games where you train a virtual pet to recognize different objects teaches the basics of pattern recognition,
Okay.
or activities that simulate how AI can learn biases from data sets. That introduces ethical awareness in a simple way. And AI powered storytelling games can be super engaging, showing how AI can be a creative tool.
Okay. So we've covered STEM, robots, AI, ML, CV, tools, projects. Looking at the big picture again, what does all this early exposure really mean for the future? How does it connect to actual career paths down the road?
It connects very directly. The tech sector is booming, and these skills are becoming fundamental across many industries. For specific STEM and robotics jobs, you've got roles like robotics research scientist, pushing the boundaries of what robots can do, or a robotics engineer actually designing and building systems for factories, hospitals, wherever, and automation specialists who figure out how to use robots and software to make processes more efficient.
Okay. And for AI and machine learning.
Huge opportunities there too. Data scientist is a big one, analyzing massive amounts of data to find insights, make predictions. Machine learning engineers are the ones building the actual learning algorithms, the models that power AI applications.
Right.
And AI researchers are focused on developing entirely new AI techniques and theories, really cutting edge stuff.
And what about computer vision specifically for kids who get fascinated by how machines see?
Yeah, CV has its own exciting paths. A vision systems engineer implements CV solutions, maybe for quality control in manufacturing or security systems. A computer vision researcher works on improving the core technology, making recognition more accurate, faster.
Mhm.
Augmented reality specialists use CV heavily to blend digital information onto the real world through phones or glasses. Think gaming, retail, training. And then there's application development focusing on image video processing, roles in autonomous systems like self driving cars and drones, and crucial work in healthcare technology using CV for medical image analysis. Lots of paths. So, as you think about all these incredible fields, maybe consider this. What complex problem that you want to solve, knowing that these fundamental building blocks, STEM, robotics, AI, ML, and computer vision, are already being put into the hands of the next generation to tinker, explore, and innovate?